So today's webinar is Intro to QGIS, and I want to emphasize to everyone on the webinar that this is a very introductory look at QGIS. I'm not going to get into a lot of the functionality. This is primarily for people who either haven't used GIS software before or who haven't used QGIS and just really want a fairly gentle introduction. I'm not assuming that you have a lot of GIS background here. So for anyone who finds this a little bit too not in-depth, not going into a lot of detail, keep in mind that I'm planning to do some more webinars coming up over the next few months, and they will get into a little bit more detail, not a lot, but at least into the functionality a little bit more. So we're starting off right here at the QGIS webpage. It's just qgis.org. I think by default it's gone into the English version of the site. QGIS, as you can see, is free and open source geographic information system software. And you literally just go to their page, click download now, and it will take, why didn't it take me there? It will take you to the page where you get to choose, it's interesting, there's, oh, there we go, where you get to choose what version you want. One of the nice things about QGIS is that there are versions for Windows as well as Mac and Linux, and all are quite stable. It's good on all platforms. So I'm not going to actually go through the process of downloading and installing it, but it is pretty simple. You click on the standalone version. That's what I've always done. Just 32 or 64-bit, depending on your computer. And the installation process is pretty simple. It'll offer you some data sets that you can install as well. Those are just sample data sets if you don't have your own data or you want to start with something sort of generic. And then you're all set. Someone before the webinar actually pointed out to me that it does download a bunch of extra stuff, like this OSGeo 4W shell, I can't remember, Saga, can't remember which others of these things are on here from QGIS. And honestly, I don't know why that is. Some of those are additional software that are kind of connected to QGIS that you can use, but honestly, all I use is the desktop version. The browser you'll see connected with QGIS is actually for browsing files, and it's similar to ArcCatalog if you've used ArcGIS. But the desktop version is the regular software. So we're going to go ahead and fire that up right now. I have version 2.6. They update and create new versions fairly often. I'm not always on top of that, but I did download version 2.6 fairly recently. Oh, and as I mentioned, what I'm doing today is going through a chapter, just briefly go back to our website, a chapter of training that I do during the summer. And just going to point out, so I've gone to our website, I clicked on Education and Training, and then under that, VCGI training opportunities. So you can see this is last summer's information. It hasn't been updated yet. Down at the bottom of this page, I do post the materials that we use in the class. And what I'm going to be going over today is basically Chapter 3. You'll see that when I finally post this over in the webinar area, it'll actually say Chapter 5 because I've changed the chapter numbers, but it is just Introduction to Quantum Projects, Data Layers in the Map View. And so if you want to, you could print this out right now and go along with me, or if you're interested in having something to follow step by step later, this is where it's posted. So again, that's the vcgi.vermont.gov in the Education and Training section, and within that it's VCGI Training Opportunities. All right, let's go back to QGIS. So when you first open up QGIS, as with pretty much any true GIS software, what you're faced with is a fairly blank page. There's obviously a bunch of icons, tools, menus up here, but the map area is blank, and the layer area or the table of contents over here on the side is also blank. What we're going to do is create a map project by bringing in map layers. So unlike what we often think of as a map, which is just sort of a thing that has a bunch of stuff on it, we are going to create a map by layering together all of the individual data layers. I'll also mention that I'm not going to address where we get data today. That's actually going to be the next webinar that is scheduled which I can mention maybe at the end because I don't remember the date right now. In a few weeks, I'll be doing a webinar about getting data and using a few different kinds of data and bringing those into a QGIS project. As I start adding data, I'll talk a little bit about the different formats or types of data that are commonly used, again, at the very basic level, so not necessarily all of them, just a few. The first thing that I generally recommend doing when people are opening up a brand new project is to set the coordinate reference system in the project properties. So I'm going to click on the project menu, go into project properties. It is by default in the right section, but if it wasn't, I would go to this section called CRS, or Coordinate Reference System. I'm going to enable on-the-fly CRS transformation. Now all of this stuff up here is here because I've used this before. If you had just downloaded and installed QGIS and had turned it on for the first time, this area up here would be blank. And if, like me, you're in Vermont, you would want to perhaps use the Vermont State Plane Coordinate System, which is what I'm going to do. If you are in a different location, you might want to do a little bit of research to find out what most of the data you're going to be working with, what coordinate system it's likely to be in, and use that as your project coordinate system. It's important because, especially because if you're getting data from different sources, there's a chance that that data will come in different coordinate systems, and your software needs to be able to transform everything to be the same so that it can all line up properly. Now, if you're not familiar with what coordinate systems are, I can't go into it in too much detail, but it's basically the XY system that's used to designate where things are based on having transformed it from a spherical Earth or sphere, what am I trying to say, globe type of a map to a flat map, to a planar map. And you can look up a little bit more information about that. But the key thing to know is just what's the coordinate system of most of the data you're going to be working with, and start with that as your base, and then everything else will get transformed into that. In some cases, it can be important to know what the coordinate system is of the data you're bringing in, just in case it doesn't have its own little projection file identifying that, because you may actually find the software asking you what that new data is so that it knows how to transform it. All right, so I've set my coordinate system. I can confirm that by looking down here. Let me just show that again, that in here, this Vermont setting has a little code associated with it, an EPSG code 32145, and I can confirm that my project has been set by looking down here in the far right corner and seeing, yes, it says EPSG 32145. All right, so here's my blank map. Let's start adding layers. The first thing I'm going to do is add what are called vector layers. And we'll talk a little bit about what vector layers are as we do this. So I just clicked on an icon up here, and notice that when I hover my cursor over these icons for just a second, it does tell me what they are, which is nice, because if you can't quite remember which icon is which type of tool, you can hover a little bit to remind you. To be honest, I generally ignore the stuff up here because most of the time I'm just making simple maps, so I'm just bringing in a file. I don't change this encoding option. I just click on Browse, and then I browse to where I know I have my data saved. So my this automatically went to the last place that I went to get data, but normally I would just navigate to the folder where it's located. So you can see this is just on my C drive, and the first thing I'm going to add is some town boundary data for Vermont. So there's my map. As you can see, our map areas where the map is being built, and over on the left we're going to see a list of our data layers as we add them. Comes in with default symbology. We're not going to talk a lot about that. I might change a little bit as we go along just for visibility's sake, but there will be a future webinar that goes into a little more detail about how you manipulate the symbology of your data layers, how they're represented in your map. There are a few different ways to add data. I usually point this out, even though, to be perfectly honest, all I ever do is click on this little button here. But you can go up to the layer menu, and you'll see Add Layer, And again, we have all the same options that we have on the toolbar. I'm going to add another vector layer. So click Browse again. This time I'm going to add some road data, transportation. So, and these particular data layers are pretty much all downloaded from the VCGI website. So these are just public statewide for the most part data layers. The naming conventions, some of the naming conventions are a little bit a little bit old at this point because this is data I downloaded years ago to use for training, but it does follow some standards that have been used in the past, if not now. So that's some roads data coming in an attractive pinky purple color. And then another way that we can add data is actually with Control-Shift-V, which you can't see, but you can imitate if you want to at some point. So Control-Shift-V opens up the add vector layer window, and this time I'll just add some school point data. One other thing I wanted to point out. I think by default, when I say I want to add some vector data, it goes to wherever I've navigated. And notice right here that it does say it's looking for Esri shapefiles. So by default, it's going to recognize this vector data that is in shapefile format. And if anyone's familiar with the shapefile, you'll know that a shapefile is really made up of, I think it's 3 to 9 files, a little pile of files. And this is just going to show each one as though it's one file because it knows that's what it's looking for, is shapefile data. If we were to change this to all files, you would now see each shapefile kind of all its little bits and parts, all the different files that make up that shapefile. And I point this out just because in case you're ever confused by that and you're not sure which of these you need to click on, if you see a bunch that have similar name, or the same name basically, different extensions, you can always check whether this has been changed and change it back to shapefile. Or if you're looking for a different type of data, remember that you might need to change this. If you're looking for CSV data or GeoJSON data, anything like that. So I'm going to go back to shapefiles for today. Schools. Okay. And there's some points. So these are all 3 of these layers are what are called vector data. And the key thing that I keep in mind about vector data is that it is an illustration of the data. So the software itself is drawing these features that we're looking at. Each point is a feature, each segment of line is a feature, each polygon or area, in this case each town, is a feature. And no matter how close I zoom in on this, it's just going to keep drawing it pretty much the same way. Even though in reality I am zooming right in on data that really isn't necessarily accurate at this level when I've zoomed in that far, it's just going to keep drawing it. The distinction that we're making here is now I'm going to add what's called raster data, and I will add this TIFF image. So as you can see, this when you add raster data, it is actually showing all of the files associated with a particular image in this case. But the one that I want to click on, I check to make sure I'm just getting the TIFF image file. So we can't really see where that is, but if I zoom in, so I'm going to illustrate a few of the things we can do here just so we can all look at this. It's going to take a second to draw. So this is some fairly high resolution orthophotography or imagery data. So the distinction here between raster data and vector data, in this case the raster data is an image. And if you haven't worked in GIS before, or I should say even if you haven't worked in GIS, if you've used Google Earth, you've probably noticed that once you zoom in enough, your image starts to look like this. It starts to pixelate. And what's happening is you are actually seeing the squares of color that make up the grid that makes up the image that we see. It's just that you've zoomed in so far, you're starting to see the dots rather than your brain being able to just kind of integrate it all into an image that makes sense. So raster data is composed of a grid of cells, and each cell has a value. In this case, it's a color photo, so each cell has a color value. In the case of a black and white photo, it would be generally a grayscale type of a value. Other types of data like LiDAR have a value that's associated with elevation rather than with actual color. It's usually represented with color or shading, but the value really has to do with elevation. So what that means is that in a particular raster file, every single bit of that area that's represented has a value. So even if this image was very simple and was all white with a black dot in the middle, every one of those cells would have a value. White, 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 and then you'd get to that black one, and then everything else would be white. But every cell has to have a value. Whereas, if we turn this off for a second, the vector data, like these points, if we were to turn off all the other layers and only leave on the school point data, the only information that's saved in this data layer is the location of these individual points. It doesn't have to save any information about the white space. It's just saving the information about the points and saying, draw a point here, and it draws it. Draw lines in these locations. And then draw polygons that have these boundaries in these areas. Whereas that imagery for the area that it covers has value for every single bit of it. Now, generally speaking, when we layer imagery and vector data, raster and vector data, the raster data, if it's imagery, often is put at the bottom of the pile rather than the top, because you notice that when it was on top, it just covers everything else up. If we put it on the bottom, initially we have an issue with, obviously we can't see it anymore, and that would be because our town boundary layer, which is currently represented by opaque areas, is obviously covering it up. So I'm going to quickly change this, and again, I'm not spending a lot of time explaining what I'm doing because it's not the focus of this webinar, but if you're interested in this, I will do a webinar later. And then I think I'll make the boundaries orange. So by changing fill style to no brush, I made it hollow, and by changing the border color to orange and maybe make it just a little bit thicker. Where that image takes a little while to draw. So I just made our town boundary data just boundaries, truly just boundaries. And I'm going to make the road data a little bit thicker just so we can see it. Leave it pink. So you can see that it's now laying on top of that image. And I'm going to change the school data just a little bit so we can see it better. And you can see that now we've got something that looks a little bit more like a map in the sense that we're representing several different things here. The town boundaries are not so important in this particular zoomed in image, but so a little bit of Montpelier, Vermont with some points designating schools, some pink lines designating major roads, obviously not all the roads in this case, just some major roads. And a little bit of an illustration of the difference there between vector data and raster data. And so I just manipulated this in a way that also illustrated another really important thing about GIS, which is that the order in which the layers appear over here on the left in the layer or the layer box or the table of contents matters. It draws the map from the bottom up. So whatever is listed on the bottom of this list is what will be drawn first, and everything else will be stacked up on top of it in the order that it appears in that list. Somebody just asked a question that I think I'll answer now because that's a good question. Does raster data automatically geographically align with vector data? Actually, the whole basis of GIS software is that the data, all of the data that is brought in is inherently geographic. It has information that is either a part of it or attached to it that indicates where it is in the world and the software then uses that to make sure everything aligns and changes scale appropriately, stays the correct scale and changes scale as you zoom in and out. And so this imagery data is not simply a photograph or even simply an orthophotograph. It's a georeferenced orthophotograph, which means it has that information. And to be honest, I can't describe exactly how, because I've heard it described before that the image itself has information associated with it, like literally that one file, but at the same time when we were looking at it, as I was adding it, you notice there were a few other files there, and one of those I know is a file associated with this image that has the information about essentially the coordinates of the corners, and having that information allows the software to know where to place it and what scale to put it at. So it's not it's inherent to the data, but it is possible to have data or to have an image that's not geographically referenced, so you do have to be a little bit careful. To be honest, I think if you tried to put in an image that didn't have that information, it would ask you for it, so you would know. I don't think you would inadvertently be able to bring it in. And then actually georeferencing an image is a whole other process that I'm not going to get into today. All right, so we're talking about the layers. So the order of the layers matters, and it's a very common thing when people first start working with GIS that they don't notice that they've kind of hidden something under something else. So anytime you're wondering where a data layer or some features went, always remember to check over here and look at your list of data layers to see what's drawing on top of what and what's opaque and what's not. So another thing is that we have added a bunch of layers here. Well, let's say we don't really want them anymore. You know, like maybe this town boundary layer, it's obviously not doing me any good right now because I'm in the middle of a town. So maybe I'll just visually turn it off because, well, it's not going to matter right now. Or maybe the pink roads I don't really need because I can obviously see the roads on the image. So maybe I don't want to obscure them. I'll just turn that off. So that's one option, obviously. It's just visually as you're interacting with your map project, you can choose to turn things on and off and see how things look. The other thing is that you might decide, I really don't need this data. I thought I needed this data, or I've used it maybe to create something else, but now it's just cluttering up my project, so I want to get rid of it. And it's simple enough to do that. There's lots of different ways, but one way is to simply right-click on the data layer itself. So put your cursor on the name of the data layer, right-click, you get this context menu, and you'll see that remove is one of your options here. So that's one way to get rid of it. You can also, oh, I thought, there it is, remove layer. So it's a little bit of a longer way to do it, but if you highlight it and click on the layer menu, you can dig around in there and see remove layer. Let's see. Okay, so there's our basic concept of the map. Is that we have brought in a variety of layers. In this case, we've brought in one raster layer, which is the image, 3 vector layers, our roads, town boundaries, and schools. We've got them layered somewhat appropriately so that we can see them all. They're actually giving us information. I've changed the symbology just a little bit so that we can see them better in the context of all the other layers. So let's say I've now made my perfect map and I want to save this so that I can come back and work on it later. I've got to start on my perfect map. I'm going to save my project. So I'm not even sure if I still use the right terminology, but I learned this as a map project. So I would click on my Save button over here, or I'm sure I could go into Project and say Save Project, and I would save this in a place that made sense to me on my computer. Perhaps down here, and I might call it Leslie's project. And you can see it'll be given a .QGIS extension. So as I do that, I want to point out that, again, if you're not familiar with GIS, the concept of saving the project, I am not saving copies of the data into that file that I just created. I am saving a project that has a bunch of references in it, and it has references that say what the path name is to these various layers that I have in here. So for instance, if I go into, so I just right-clicked on the data layer and I can go into the properties for that data layer, and in general you can see that one of the pieces of information in here is the layer source. So this is saying where is the project going to go and find this data layer. If I shut this down now that I've saved it and open it up again later, it's immediately just going to look for this data layer right here, which means that if I move that data layer, it's not going to work. And when you open QGIS, if you've moved data, it will immediately give you a little notification that this data layer is not found, and it will give you the opportunity to repoint where it is. But as long as the data stays where it was originally, it has no problem. It opens it up. This same data layer can be referenced by many different projects all at the same time. And that's not a problem because it's not actually creating copies of the data. It's just sort of pointing at the data. It also, the project is also saving information about how I symbolize the data. So the fact that I turned these school points into red stars is saved within the project, not within the data. I haven't changed the data at all by doing that. All I've done is refer to the data and say, this is how I would like it to be symbolized in this project. Obviously the same thing with the roads and the town boundaries. If I had created labels so far in this project, it would also save that information. It will also save information about the moment that I save it, how zoomed in I am, and where I'm zoomed into. And when I open it again later, it'll be at that same spot, which doesn't matter that much because I can still zoom in and out all I want, but it will remember that. That's one of the things that it will remember. Okay, so that's my conceptual thing that I want to get across. It's just the idea of saving the project. I'm not saving copies of data. Another thing to remember is we can do two different things. We can bring data into a project where we click on our icon, we go and browse to the data. We say, yep, that's the data I want. Click open and it adds it to our map project. Another thing we can do is to open an existing project. So I'm right now going to get out of this project and open up a new project. So I'm going to click on the open folder over here in the upper left, and I'm going to navigate to the project that I want to open. So there's the project I just saved, but right now I'm going to open a new project called Chapter 5. And because I had already saved my other project, it didn't ask me whether I wanted to save it. If I hadn't saved it yet, it would ask me if I want to save it. And I could have said, nope, discards, just practice, or I could have saved it at that point. So here's another project, very similar, as you can see. Still the state of Vermont, showing town boundaries with some major roads. Again, a point data layer. This time I've got airports with a little symbol that actually looks like an airplane. And all right, now I'm going to be a little more explicit about some of these tools and icons I've been using up here in the top. Many of the most commonly used ones are zoom in and zoom out, concepts that everybody's familiar with. In GIS software, it's a little different than in, say, Google Maps or Google Earth, in that we generally use this zoom in and out tool that looks a little bit like a magnifying glass. And what I'm doing is I'm drawing a box. I'm right-handed, so I assume that's why I tend to start in the upper left corner of my imagined box, which I kind of imagine before I start. I push down my left mouse button, hold it down as I drag my box. So I go from the upper left corner up here to the bottom right corner. And as soon as I let go of my mouse button, it will draw to that approximate extent. The zoom out button, usually you don't draw a box for that because that wouldn't really make sense, so I just sort of click on the map and it zooms back out, sort of a predetermined jump each time. It's convenient to use your zoom in tool when you know you want to go to a very particular area. You don't have to click, click, click to zoom in a million times. You can just draw your box around your area and zoom right into it. If you inadvertently zoom in where you don't mean to or something, if you bump something, we do have this zoom last option. So that just takes you back to where you were at that last zoom level. You can kind of go back and forth once you've done that a couple times. Also, if you zoom way in and suddenly you're lost and you can't figure out where you are, where you want to be, you can pop right back out to full. And in this case, or in any case, full will mean the largest extent of any of the data layers in your project. So if you have a world data layer, it's going to zoom you out to world. Obviously, since state of Vermont is the biggest extent I have, I'm zooming out to that extent. Once you are zoomed into a level that you kind of like, but you're not quite centered the way you want to, you can switch your cursor to a pan tool. That's the little hand, and then I'm just clicking my left button, holding it down, dragging, and it just drags the map around a bit. I think those are all the zoom tools I want to point out. Keep in mind that what we're changing as we do this zooming in and out is the extent. So the extent is defined by the bounding coordinates of whatever we're looking at, in this case this box. Just trying to make sure I don't skip over anything. Another way to change the extent, oh, and I forgot to point out that when I opened this new project, if we look down in the bottom right corner, once again, I have this EPSG set to 32145. That's the code associated with the Vermont State Plane Coordinate System. And one of the reasons it's important to set your coordinate system is so that the software knows what units are being used to indicate locations. So if we think about, like, what is the location of this airport, it has a set of coordinates associated with it. So in the case of the Vermont State Plane System, which is measured in meters, it is, and actually we can look down, if we look down at the bottom of the screen where it says coordinate, when I put my cursor over that airplane, this airport is, I have to get my numbers right, 491,080 meters to the east of the 00 point of this coordinate system, 225,949 meters north. And so if you remember a grid system, just like in geometry or whatever it is when we were in school, you're just counting over a certain number of meters to the east from the starting point and a certain number of meters north in a grid. And that's how this system works in terms of designating where things are. And knowing that it's meters allows the software to also tell you the scale that we're at any particular moment. So just to the right of the coordinate is the scale, and right now we're at a scale of 1 to 268,912. This way of expressing scale, which is called a relative fraction, is unitless. So that means that we don't have to say miles or meters or anything else in association with this number, because it's assumed that whatever units you want to talk about, it's the same on both sides of this equation. So this might mean 1 inch, if I sit here and measure 1 inch on my computer screen, is equal to 268,912 inches in real life. And if I were to do the conversion to figure out maybe how many miles that was, that would make sense. But in the case of this fraction, it's the same units on both sides. You have to convert to get a different unit or different measurement. So that's one of the reasons it's important to set your coordinate reference system so that you can get an accurate scale and measurement, because you can measure on your screen as well. But before I move on to measurement, so remember we had this icon up here where we can zoom to full extent. We can also zoom to different extents than full. So if I add one more vector layer in here called, it's not really called this, but it's management areas. It's management areas of the of the Green Mountain National Forest. And I'm just going to change the color to green. Well, it's not that great, but so as you can see, the Green Mountain National Forest does not obviously have the full extent of the state, and I can right-click on that data layer and say zoom to that layer, and it will zoom me into an extent that allows me to see that whole layer, but it doesn't worry about the fact that it can't see some of the other layers. All right, so that's just an example of the fact that you can do a zoom to extent, which can be very useful. You may have noticed I used that when I had the ortho image. Often, if you put data on your map that is really a fairly small extent, and you may or may not even know where it is, it's very useful to be able to zoom to extent, zoom to the layer extent, rather. Okay. All right. Down here where we have the scale at the very bottom of the screen, I can also choose by clicking on this little arrow to zoom to a predetermined scale. So if I want to see what a 1 to 1 million scale looks like, or a 1 to 250,000 scale, I can change the extent that way. I can also actually just highlight and change this scale if I want to, by typing in whatever I want. And notice that I only have to type in the right hand of that 1 to something scale. So when I type in 400,000, I'm really typing in 1 to 400. I'm really indicating that I want to do 1 to 400,000. Then I just hit the Enter key to get it to actually zoom to that scale. Okay. All right, so now I will talk about the measurement tool. Now that we sort of have a sense of units, we're measuring in meters, or I shouldn't say we're measuring. The coordinate system is in meters, so our coordinates down here are being measured in meters. We do not have to measure in meters. And as you can see, my measure tool, which I just chose measure line, my measure tool is measuring in feet. And I can choose to maybe measure this segment of road by clicking with my left mouse. I could try to follow the road carefully, or I could do a more rough approximation. And I can say, okay, that bit of road is about 7.5 miles long. And then when I'm ready to close, I just click close. I want to point out that you can change things like the units of your measurement tool in settings, the settings menu, options, and if we go into the map tools, notice there's all sorts of other things here, but we want to go into map tools, and there's a few different things you can set in here. There's actually a lot of different things, obviously, that you can set in your options menu. But the measure tools right here, I can control the color of that little line that it draws temporarily. That's just a temporary line to show you where you've clicked and where you're measuring. It's not going to stay. There's not any way to make that stay. But you can change your color. You can change the number of decimal places that show up in that measurement. And you can also change the units here. So I could go back to meters. If I do feet, you notice that it did automatically do miles when I got long enough. And then you can also change your predefined scales that we saw in the scale box down at the bottom. So now I just changed it to be 2 decimal places rather than 4, and you can see that it is indeed 2 decimal places. So I could measure the perimeter of a town and get an idea of how many miles it is to walk around the edge of the town. We also have area measurement, so I could also measure the area of a town or parcel, if I had parcel data, get an approximation at least. You can see this town is about a little more than 41 square miles. Okay, close that up. Okay, I am going to finish up by talking a little bit about what I'm imagining some of you are asking as you're watching this, which is, well, what about all this data? What do I know about this data? Usually people do start to think about this. especially maybe orthophotography, the image that we saw earlier. You might ask, well, when was that taken? How old is it? Some of this data, like this roads data, actually, it's not complete. It's called major roads. So how was that decided? What are major roads? What's actually included in this data layer? If we look at these management areas in the Green Mountain National Forest, you might wonder why they're broken up into all these different polygons. And the airports, we could have a lot of questions about the airports, but since we're not really looking at the attribute data right now, we may or may not have them. So let's briefly go back to the VCGI website because, as I mentioned, this is where all of this data came from. So this is where you would go at VCGI's website if you were looking for data. Let's pretend for a minute we're actually going to go get that airport data. So I just clicked on data and imagery and a couple of different search options. We're going to look at the keyword, use the keyword search. So here's the data layer, airport locations. And notice that for every single data layer that you find at our website, you will see this little icon that's a green circle with a question mark in it. And this is your link to more information or metadata. Initially, you get this page that's kind of a metadata light page. It gives you the basic information that you generally want to know. How recently was this updated? Oh, this was updated very recently. It's point data. Is it statewide? Yes, it's the whole state. The source map, this gives you an idea of at least a range of scale accuracy. So keep in mind that if you're zoomed in past, certainly past 1 to 5,000, and in some cases probably past 1 to 24,000, the spatial accuracy of your point is probably not all that valid. You have to be a little careful with GIS data zooming in way past the intended accuracy of something, of a particular data layer or feature. But we also have the link to the full metadata, which you may or may not be interested in. But if you have questions about your data, it's a good idea to get in here a little bit. Up at the top, so this is a file. It's really just a text file. It's being shown in an HTML format here, but it's just a file that has information about the data. So questions that you might have about a particular data layer, not about a map, but about a data layer. In this case, it's the airport data. The originator of the data, so this comes from our Agency of Transportation, not surprisingly. The age, if we click on description, you hopefully get a decent little abstract. For some data layers, this can be incredibly important because it'll give you a little bit of insight into how the data was created, why it was created, whether it's really complete or not. Gives you actual point of contact if you want to contact someone with more questions. And then some of the important things are attribute information, which we didn't really go into today, but I'm going to go into that more in some of the other webinars. But if you have questions about the information associated with each feature, like, let's see, the town that an airport's located in, the contact information for the manager, just knowing what some of these somewhat cryptic attributes are called, or what they really mean, can be very useful. Some of the most basic things that can be very useful are just the age and where it came from. So that's metadata. So a quick dip into accessing data from us. But keep in mind that if you ever are getting Vermont data, you should always be able to access the metadata at our website at least. In many cases, it'll be bundled up with the data as you download it. If you download a pre-bundled, pre-zipped statewide layer, it will often have the metadata in it. The more custom ways of downloading the data often don't have the metadata in there, so remember that you can always come back and find it. If you get data from other sources, it's a really good idea to look for some kind of a link to metadata, or if you're getting it from a person, ask them about it. And if they don't have something already created, ask them to write a paragraph to describe as much about the data as you can get. Oh, I know what else I was going to point out in there, sorry. The coordinate system. So if you are ever getting data and you have questions about the coordinate system, it's not obvious, that's one of the things you can look for in the metadata. So you can see state plane coordinate system. This USGS zone 4400 is actually what indicates that it's the Vermont state plane coordinate system, and then it tells you the information of the origin, or the location, sorry, of the origin of our grid, our state plane grid. Okay, I think that is most of what I wanted to cover today, so let me just take a look at the questions and see what I haven't answered. And this is a good time, if you have questions, to go ahead and start sending them in. Okay, so I answered that first question about whether raster data automatically lines up with vector data. In general, the data itself needs to have that information in it to work in the GIS. All right, so someone asked about selecting a feature or features and creating a layer from it. It's a little bit beyond what we're doing today, but I guess I can, well, let me just answer some other questions. I can come back to that. Someone asked, can you change coordinate systems mid-project? Yes, you certainly can. I'm not sure that you would want to do that. I think as long as all of the data layers have projection files, which a projection file associated with a data layer really is like a little translation file. It just says my native language is Vermont State Plane, or my native language is some other coordinate system, which means that if you change, it should be able to just change everything along with it. So if I go ahead and change this to WGS 84, what you'll notice is that it's going to look a little funny in this different projection, but it does just automatically change everything, so it's not really a problem. So yeah, I would say the answer is yes. If anybody knows of reasons that you maybe really don't want to do that, I don't think I know off the top of my head. If you had any, no, I think anything you brought in, you would have had to indicate what its native coordinate system was, so it would, the project would essentially save that information and be able to deal with it. Oh, that's a good question. What is the tool to the left of the pan tool? You know, this is a tool that I noticed and I have not tried it. Oh, why is it not telling me what it is? Huh. There we go. Touch, zoom, and pan. Huh. I don't know what that means. Well, I apologize. I haven't figured out what that is yet, but it is called touch, zoom, and pan. That is as much as I know. It's not obvious to me. Sorry, I have to expand my question thing to read it. Changing the measurement tools. Yes. Okay. So remember I mentioned that the measurement tool, right now mine is set to measure in feet, which then gets transformed to miles. I can go up to settings, the settings menu, options, and you have to get into the map tools area in here, and this is where we see the measure tool. Things that I can change: the color, decimal places, and measurement units. So that was settings, options, map tools. And if you get that document that I referred to earlier, you will see that there's a little mention of it in there. It's not a big section, but there's a little mention of the fact that you can change that. Okay. Can we create our own shapefiles? Yes. Get it from other sources, definitely. So you can create your own shapefiles. Again, that's not something I'm going into today, but I will actually in the next, briefly in the next webinar, which is going to be about accessing, actually the next webinar is about accessing data, both in terms of searching for it, finding it on different websites, how you deal with the fact that it might come in different coordinate systems, or it might be a CSV file rather than a shapefile, and also the fact that you can edit data and create data from scratch. So yes, you can do all of that in QGIS, and we'll touch on all of that in the next webinar if you're interested in that. Yes, somebody pointed out that this icon up here, that touch, what is it called again? Touch, pan and zoom is for if you have a touch screen. That's exactly what I was thinking when I looked at it, and I was looking at my screen thinking, I can't do anything with that. So this is for if you're using QGIS on something that does have a touch screen. 2 layers you're adding to your map have different source coordinate systems. So someone asks, what if you're adding data that has different source coordinate systems? That is actually the whole point of setting our project properties at the beginning. Because remember, the thing that I clicked in order to set the properties, the coordinate reference system, is this thing that says enable on-the-fly CRS transformation. And what that actually means is, as I bring a data layer in, as long as the software is able to recognize what that data layer's coordinate system is, so say it's New Hampshire state plane feet, which is their standard, it would say, oh, this is New Hampshire state plane feet. Well, gosh, this project is in Vermont state plane meters, so I guess I need to do a mathematical transformation, which, you know, the magic of computer software can do that. It's not a big deal. As long as it has both pieces of information, the project coordinate system and the data coordinate system, if it's different, it can just do a transformation, and it'll essentially turn that New Hampshire data into Vermont state plane. It'll mathematically change it into Vermont state plane, and then everything will line up properly. So yes, that is the key is knowing both. So if you've set your project, you obviously, the software knows what that is. If you bring data in that doesn't have a projection file as part of the shapefile, it will actually ask you, what is this? And if you know what it is, it's not a big deal, because then you'll just say, oh, this is New Hampshire state plane feet, and it'll say, okay, and it'll do the transformation. If you don't know what your data is, it can be a problem, because then it doesn't have the information it needs to transform it. Are there any base maps within QGIS? So QGIS itself, the software, does not have base maps, but there are many other ways to add data, and again, I'm going to talk about this more in the next webinar, including adding a web map service. So that's one way to add in a base map that involves having it sort of stream over the internet rather than downloading data onto your local drive and then accessing it here. So that's one thing that I will talk about in the next webinar. And I am not going to remember where it is, but there are, maybe it's in the plugins. There are ways to directly connect to things like OpenStreetMap. And I'm just I haven't done it that much, so I'm sort of blanking on how you do that, if it's through the plugins or if it's just adding it as a service. OSM, no, that's for editing. So the short answer is yes, there are plenty of ways to add base maps in here, and I will talk about at least one of them next webinar in a couple of weeks. So maybe I will quickly, since I think that's all the questions, I'm going to quickly go over to my calendar to confirm the date of that next webinar. Okay, so February 10th, a Tuesday, February 10th at 1:30. I'll be doing the next webinar, and that one's going to be about data acquisition and transformation. And again, it's just kind of running through a few different things that you might face as you go out there looking for data. Bringing data in from a GPS, adding a delimited text layer, setting coordinate reference systems, just going through the process of downloading data from someone, from both VCGI and from another website. Selection process. Oh, and yeah, I can quickly do the selection thing. All right, so I think that's pretty much everything I intended to cover today. I'm going to quickly answer this person's question about selecting. Again, this will be covered in much more detail in a future webinar for anybody that wants to sign off now and not get exposed to something that's going to be very brief. So there is this option to select features. Let me highlight a data layer. So I'm highlighting the airports. I'm going to select features by polygon, which means I'm going to draw a polygon by clicking. Each time I click, it creates a vertex. When I double click, I'm done. Oops. If it notices that I don't, if I right-click, sorry, not double-click, and I'm not sure everybody can see that if I zoom in a little bit. There's a little yellow box around each of these airports that was within the area that I selected. I think I can now do a right-click on my airports, say Save As. Notice that I have this option to save only selected features. So these are my 3 selected features out of all the airports. I'm saying I only want to save these 3, and I'm saying I want to save, I'm basically creating a new data layer, a new shapefile. Esri shapefile, I would give it a name. I'm not going to actually do this, but I would give it a name here. I would, let's see, so layer CRS, this is where you're telling it what coordinate reference system you want it to have. I want to say yes, the same as what it started out with. I could change this to something else if the project CRS was different. A couple of options. Simplest version, I don't save symbology or anything else, and I would just click on OK. So this is where I tell it what I want to name it and where I want to save it. This is what type of file. There's a few different options in there, as you can see. And then the key thing here, because I'm creating data layer out of selected features, is clicking this box right here. All right, so that's a very quick mention of that. Okay. Thank you very much, everybody. I hope this was useful, and if you're interested in just a little bit more depth, I don't go terribly in depth in any of these, I'll warn you, but if you're interested in a little bit more, there will be more coming up. I haven't scheduled anything past February because our organization is going through a change, and I'm going to be hooking up with a new GoToWebinar account hopefully in February, and I'll be able to start scheduling things for March. But right at the moment I can't do that, so I apologize for leaving that a little bit late. So hope everybody has a good day and goes out and gets QGIS if you haven't already. It's pretty fun to work with. Thanks.